Hi, today we will be learning interference of light. We know that interference takes place when the two waves are coming from coherent source and the waves are at constant phase difference in time. But light comes from atoms in an ordinary source, and in a small element you have infinite number of atoms. And these atoms are emanating light waves. So these light waves are in different phases. And also the phase difference in time changes. So the general sources of light are not coherent sources. So we cannot observe interference of light in general source of light. Now Thomas Young of England in 1801 devised a very good experiment. He set up a very good device to obtain interference of light wave. And he obtained the interference. He obtained alternate maxima and alternate minima. For that he took 3 screens, 2 opaque screens parallelly placed, and a third screen on which he had to obtain interference pattern. So in first screen he made one single slit which is perpendicular to this axis. The axis which is passing through all the 3 horizontal axis passing through all the 3 perpendicular planes. And he took two slits. He took 2 slits in the second screen which are equidistant from this axis, the bisector plane or bisector axis. So this is what he devised, and he kept all the thing in a dark room. Now when a white light falls on this first screen at this point, then a source is created, a source which is a single point. Now from a single point waves emanate and goes to these 2 points. So whatever phase difference will occur at this single point in first your screen will be incorporated, will be manifested in the phase difference of, in the phases of the 2 disturbances at these 2 slits. So here the phase difference is locked, phase difference of the 2 waves coming out from these 2 slits locked. Now the phase difference of the 2 disturbances coming from these 2 slits will not change in time. They will remain constant. So after that, light from one source is divided into 2. So any phase change in slit 1 will be incorporated, manifested in the 2 slits of the screen. So the 2 slits will be locked in phase. Means the phase difference of the 2 waves will remain constant. Now here is a symbolic diagram to obtain interference pattern due to light waves. Here you have 2 slits, slit 1 and slit 2, and distance between the 2 slits is small d. Then after you have a parallelly placed screen at a large distance, little bit large distance, that is called, that I have taken capital D. So this point which is at equatorial bisector, this point is at equidistant from the source. So path difference is 0 and phase difference is 0, and therefore the 2 waves will interfere at this very point. There will be constructive interference between the waves, and a maxima will be obtained at this point O. Now let us consider the waveform at point P. There is a point P which is x distance above the middle point O. Now you have 2 triangles PS2Q, PS1R. So let us find H2P square. In this right angle triangle, hypotenuse square is equal to base square plus perpendicular square. And similarly in this triangle, hypotenuse S1P square is equal to base square S1X, that is your D square, and plus this distance PR square. So you will find that in this case that PQ is equal to X plus D by 2. And in second case, this distance is your X minus D by 2. Now when you add the two, when you subtract the two from subtract smaller one from bigger one, you will find 2xd. Now you know that a square minus b square is equal to a plus b into a minus b. So finally you get a path difference, H2P minus S1P. So all these things we were doing to find path difference. That is equal to 2xd upon the addition of H2P plus S1P. So now let us consider if this distance is large, 100 centimeter. This distance is very small, 0.1 centimeter, and this x is your 1 centimeter. And putting all these in equation 1 only. In this equation 1, when you put value of x, that is 1, and value of d by 2, that is 0.05, it will nearly come equal to 1, very negligible. Before your 100 square means 10,000, before 10,000 this 1 is very small. So this can be neglected, and finally you get that H2P comes equal to D only. Similarly, S1P also comes nearly equal to D. So in this equation, here you have equation. Yes, in equation A, H2P plus S1P is equal to 2D. Now 2 are cancelled from numerator and denominator, and then path difference, that is H2P minus S1P, del x, it is del x, and there will be constructive interference. There will be maxima at all those points if this path difference is equal to n lambda. And n lambda when put equal to this path difference, that is xd upon d, you get x, that is the distance from the origin, from the middle point to the point where the fringe has been made. This is the distance. Now when you put n is equal to 1, 2, 3, etc., then you will find the distances of the fringes from the origin, from the O, are lambda d upon d, 2 lambda d upon d, 3 lambda d upon d, and so on. So what is the fringe width? These are the alternative distances. So for fringe width, we will subtract these alternate distances, and you will find that the fringe width come equal to lambda d upon d. So this is how your young obtain alternate bright and dark fringes on the screen that are similar to fringe obtained on the surface of water. So interference takes place over there, and the width of this fringe is equal to lambda d upon d. Now you can see that here d is a constant, small d, the distance between the two slit is a constant, and wavelength, if you have taken only one color, then wavelength also is a constant. So it implies that the fringe width in interference pattern is constant. Means same thickness of fringe width. Every fringe is of same thickness. Now what happens when you change the position of this first slit S, and it is displaced to a distance and it is brought to a point S dash, so that the angle made in between is delta. Here S, if you take a point here A, SA S dash is equal to delta, then you will find that fringes have shifted on the negative side by the same angle, minus delta. Here I have brought the point horizontally away from S. This is at an angle delta. So your fringe pattern will be deviated, changed by the same angle on the other side by minus delta. And you will find that the fringes and all the points will remain along a straight path. Now, pattern of these fringes. You will find that when the distance between the screen and the sources is small, then you will find that these fringes are in the shape of hyperbola. Because when you find the path difference, here you have path difference, and this path difference is a constant, and this is a property of hyperbola, that if path difference is constant, if you put a pencil at the joining of these two paths, let us suppose that we have taken two strings and we have placed one pencil, and when you move the pencil on a perpendicular wall placed parallel to the plane of slits, then you will find that hyperbola is forming at near place. So the shape of the fringes is hyperbolic when distance of a screen is small. And when screen goes to a very large distance, then the shape of fringes become straight. So this is all about your Young's double slit experiment. He observed interference patterns. He observed alternate maxima and minima. Then he also found the width of a single fringe. That is your d lambda by small d.